Welcome to Brain Vision.
As the airplane accelerates towards the right, what happens is that the table will try to slide below our cup of coffee. But luckily, the frictional forces can save us. So what happens with the frictional force is that as the table tries to slide below our cup of coffee to the right, the frictional force will try to bring the cup of coffee together with the table to the right. So the frictional force that appears is pointing to the right like this. Additionally, of course, there are the normal force and the weight force acting on that cup of coffee. So how can we calculate what is the maximum possible frictional force that can act on our cup of coffee? Well, the answer for this question is very simple. The maximum frictional force is equal to the static frictional coefficient times the normal force that acts on our cup of coffee. In this question, the weight is precisely counterbalanced by the normal force. Therefore, the normal force is equal in magnitude to the weight force. So the frictional force is given by the static frictional coefficient times the weight force. And this is equal to the static frictional coefficient times the mass of that cup of coffee times the acceleration of gravity. Then we can relate this frictional force with the plane acceleration using Newton's second law. So Newton's second law tells us that the net force that acts on that cup of coffee is equal to the mass of the cup of coffee times its acceleration. Then let's suppose that the cup of coffee acceleration is equal to the plane acceleration, because in this situation it isn't sliding over the table. So we have the static frictional coefficient times the mass of the cup of coffee times the gravitational acceleration being equal to the mass of that cup of coffee times its acceleration. We have mass on both sides, so we can simplify and we get the conclusion that the maximum possible acceleration that the plane can have in order for the cup of coffee not to slide over that table is equal to the static frictional coefficient times the acceleration of gravity. As usual, we use the acceleration of gravity as approximately 9.8 meters per second squared to get an acceleration that is given by 0.3 times 9.8. Then the maximum acceleration that the plane can have is approximately 2.9 meters per second squared. And this is our final answer.